Alright guys, here are selected problems for us here on here that I just thought would be representative and that some of you guys asked for. Okay, number 4, limit as x approaches negative 2 from the left and from the right. As x gets closer to negative 2 from the left, the y values are getting closer and closer to, well, they're always staying at 5, so that is 5. As x approaches 2 from the right, f of x, or the y values, get closer and closer to negative 3, because they're always 3, the y values are 3 as it gets closer to 2. Okay, so we also know that this right here, oops, stop the limit as x approaches 2 of f of x itself would not exist because the left and the right don't equal each other. Okay. Alright, number 6. F and g are continuous on 0 to 4. Could f of x over g of x possibly be discontinuous at a point, of 0, 4? Provide an example. Okay, well, how about this? We want where it's discontinuous. What about something as simple as this? F of x equals x, that's continuous everywhere, and g of x, x minus 4, that's continuous everywhere, but f of x over g of x is x over x minus 4. Well, that's discontinuous at x equals 4. In fact, there's an asymptote there. So that would be an example of our function f of x over g of x that's discontinuous there. Okay, I was going to go to number 7 here. The average rate of change. So it's the average rate of change. That's f of b minus f of a over b minus a. Compare that to the average value of a function. So on the interval 3 to 5, so that's just going to be f of 5 minus f of negative 3 over 5 minus 3. Okay, so if you do that, simplifying, you will get, got the answers over here for number 7, you'll get B, 118. Okay, number 8, the equation of the normal line. The normal line, remember, if this is the tangent line, the normal line is just perpendicular to it. So let's find the tangent line at that point. Well, y prime is 3 minus 4x. So y prime at negative 5 is 3 times, 3 minus 4 times negative 5 is 3 plus 20, which is 23. So the equation of the tangent line would be y plus 65 equals the slope 23 times x plus 5. That's the tangent line. So the normal line is y plus 65 equals the opposite reciprocal, right? Because that's the perpendicular slope, x plus 5, which if you put that in standard form here, that's going to end up being d, which is that guy right there. Okay. All right, look at number 11. U and v are differentiable functions. Find the derivative of uv. Well, that's just a product rule, so that's first times the derivative of the second plus the second times the derivative of the first. And we want it at 2, so it's going to be u of 2 times v prime at 2 plus v of 2 times u prime at 2. So I just wanted you to remember the product rule in this kind of different notation like that. So u of 2 is 6. times v prime of 2 is negative 5, plus v of 2 is negative 3, times u prime of 2 is 4. And if you add those all up, you will get C, negative 42. I guess it'd probably be easier for me just to do it than to look it up on the answers. So there we go on that guy. We'll take a look at a couple more on this. Sorry, my allergies are killing me right now. So we got number 21. Find the local extrema, analytic method, so numbers don't graph it. So I'm going to find the critical values. Y prime is 4x cubed minus 36x. So set that equal to 0. I'm going to divide by 4. X cubed minus 9x equals 0. Factor x times x squared minus 9 equals 0. So that's going to be x times x plus 3 times x minus 3 equals 0. So my critical points are 0, 3, and negative 3. So I got negative 3, 0, and 3. And I just want to figure out where y is increasing or decreasing. Okay, so let's plug values in. Always plug them into the factored form. It makes it so much easier. So a big negative number, negative, negative, negative. Y prime is negative. Plug in negative 1, negative, positive, negative. Y prime is positive. Plug in positive 1, positive, positive, negative. Y prime is negative, and then positive number. They're all positive. So let's see, it's going to be decreasing, increasing, decreasing, increasing. So at x equals 3, negative 3 is a minimum, relative minimum. X equals 0 is a relative max. And x equals 3 is a relative minimum. That's what I'm looking at here. If I, oops, excuse me, sorry if I didn't mess this up. So it's decreasing, then increasing, then decreasing, then increasing. Sorry. Okay, and then from here, we just have to figure out the y values to figure out what we got here. So we got a local minimum at negative 3 and 3, and then local max at 0. So it looks like we're going to end up being at 3 if you verify the y values there. All right. Where is it? Just looking at 22, we just want to know where it's increasing and decreasing. We're just interested in where is f prime of x positive or negative on something like that for 22. And I'm going to cut this one off right here, and then I'll pick up another one on the last set.